In this video, we are going to learn about array versus linked list. So there are many factors in array as well as linked list. So first factor is cost of accessing an element in an array as well as linked list. So we'll see what is the cost of accessing an element in an array. So now consider an array. For example, the array name is say A. Okay, I have how many elements? 1, 2, 3, 4 and 5 elements in an array. So here I have 5 elements. For example, if I want to access A of 2, for example, this is I 0, 1, 2, 3, 4, A of 2 I want to access. How can I access? I can access directly. I can go to A of 2 and get the element 2. Or if I want to access A of 3, I can directly go to A of 3 and get the value of 9. So how the cost of accessing an element in array is handled. Now see, for example, if you have A of 2, you have to calculate base address. What is my base address for array? It is the first element. Base address is always, it will start from 0 and the index value is, for example, I have given here 100 is my base address. Okay, so normally hexadecimal only address will be, but I am just giving you for your reference 100, 104, 108 and so on. I have taken here the size of the arrays for integer is 4 bytes, depends on the processor. I have taken for integer 4 bytes. So this is my integer array and each byte takes 4 bytes of memory. So now here my base address is 100 plus what is my I value? 2 into the size of data type. So what will I get? 108. So directly it will go to A of 108 and I'll get the value of 2. So the cost of accessing an element in an array is O of 1 only, because it directly goes to the particular element and gets the value. Whereas in linked list, so you have linked list, it is dynamically allocated, so it will store based on the address which is linked. So for example, if I want to access 2, I have to know the link of the address, then only I can access the element of 2. So I have here 3 elements in a linked list. So always in a linked list, I have a pointer initially which is pointing to the first address in the linked list. So the head pointer, for example, my first pointer is my head pointer, that is always pointing to the first element. So the head is always pointing to the first element. So if I want to access the element 3 in the linked list, I can't go directly to the element 3. So I have to, the head pointer always points to the first address. So what is my initial address? 1000. So it will go to 1000. In 1000, what link is given here? The next address is given as 2000. So again it will go to 2000. My element is 2. Then again in 2, I have given the link as the next address as 3000. So in 3000, my element is 3. So in linked list, I can't go directly to access the element through the head pointer. From the beginning only, I can access the element for accessing any particular element in the linked list. So the time complexity for accessing an element in linked list is order of n. It depends on the number of elements in the linked list. So this is one difference for array versus linked list. Hope you understood. So next factor is memory requirement, and then we'll see memory utilization. So there is a difference between memory requirement and memory utilization. So in memory requirement in array is always less compared to linked list. In linked list, the memory requirement is more. How it is possible? See, we'll see with an example. Consider this array. So how many elements are there in an array? 7 elements. So it always starts with the index 0. So 0, 1, 2, 3, 4, 5 and 6. But I have only used here only 3 elements. Other 4 elements are not used, unused. So the maximum capacity of this array is 7 elements. I can store 7 elements. So how many elements I have used here? 1, 2 and 3 elements I have used here. Okay. So here total number of memory capacity, for example, if I take 4 bytes for the integer, so each allocation size is 4 bytes. So 7 into 4 is equal to 28 bytes is allocated. Whereas in linked list, it is dynamically allocated. So there is no need to, there is no fixed, previously we no need to fix any element for capacity for storage. So dynamically it will be allocated. So now here, for example, the same 3 elements I'm storing in the linked list dynamically means how much memory capacity it will take. So in linked list you have 2 parts, namely one is your data part and one is your link part. That is, this will also carry 4 bytes, this will also carry 4 bytes. So to store one value itself, it will take totally 8 bytes. So how many elements I'm using in the linked list? 3 elements I'm using in the linked list. So 8 into 3, it carries only 24 bytes. So the memory requirement in array is always less and memory requirement in linked list is always more only. Okay, so here suppose for example if I want to add one more new I want to insert a new element in the linked list, again it will take again 8 bytes. So how much it will take? 8 into 4 is equal to 28 bytes it will take. But whereas in array, just simply I need to just enter the element, because already the memory capacity I have given the maximum capacity for this array as 7. So I can directly store. So it will take 28 bytes only. But in linked list, if I add one more element, it will take again one more both 4 and 4 for data part as well as address part. It will carry 8 bytes. Again if I store another element, if I want to add another element, it will again take 8 into 1, 2, 3, 4 and 5. So suppose if I'm using 7 elements, so 8 into 7, that much memory bytes it will take for linked list. Totally 56 bytes will be taken for linked list, but in array it is only taking 28 bytes. So memory requirement is always less compared to linked list. Whereas memory utilization is efficient in linked list but not efficient in array. Why? Because we have wastage of memory in array. Suppose if I'm having the maximum capacity, here I'm using 7 elements, but only I'm using 3 elements.